Right now, somewhere deep in the North Pacific Ocean, a whale is singing. Not the humpback whale with its famous, complex, ever-changing songs. A different whale, one that sings at a frequency so low that no other whale of its kind can hear it. This whale has been tracked since 1989, when hydrophones operated by the United States Navy first detected its voice moving through the deep ocean. It sings at 52 hertz, far below the frequency range used by blue whales and fin whales, the species it most closely resembles in its movement patterns and migration routes. Scientists have been listening to it for over 30 years. They have followed its migrations across the North Pacific. They have heard it call in the dark, cold depths. But in over 3 decades of listening, no other whale has ever been recorded responding to it. Its calls go unanswered. It is, in the most literal sense, the loneliest voice in the ocean. And the ocean, at the depths where this whale sings, is completely dark. The sunlight that warms the surface does not reach there. The temperature is just above freezing. The pressure is many times what you experience at sea level. The water is still and cold and dark, and in that cold, dark stillness, a voice has been moving through it for 30 years, singing and swimming and singing again, calling into a silence that calls back nothing. There is something deeply calming about this image. The vastness of the ocean, the depth of the quiet, the whale moving through the dark, sustained by the sea, unhurried, the ocean floor beneath it, silent and ancient, and the water itself, cycling and drifting and carrying the song outward at 1,500 meters per second in every direction until the sound fades below the level that any instrument can detect. Tonight, we are going to rest with this planet, not the universe, not distant galaxies and black holes and the far future of space-time. Just this one world, the one you are lying on right now, the one whose gravity is gently and continuously holding you in place against its surface, the one whose atmosphere is providing the oxygen your body is using to breathe without you having to think about it, the one whose molten iron core is generating the magnetic field that deflects the solar wind and keeps the planet's air from being stripped away. Just this one world, which is, when you look at it closely enough, as extraordinary as anything in the observable universe. Everything I am going to tell you is true. Every number, every depth, every age, every detail. The Earth is more extraordinary than most of us fully appreciate, and tonight it is your bedtime story. Take a breath, a slow, full breath in, letting your lungs expand completely. Hold it for just a moment, feeling the stillness, and breathe out slowly all the way, feeling your body settle. Let your muscles release. Let your thoughts slow. The planet is holding you. It has been holding you every moment of your life. It is very good at this, and tonight you can rest completely in that holding. Let us begin at the beginning. 4.54 billion years ago, there was no Earth. There was a young sun at the center of a disk of gas and dust and rock and ice, the remnant of the cloud that had collapsed under gravity to form the star. Within this disk, the material was slowly clumping together under gravity. Dust grains stuck together, then pebbles, then boulders, then objects the size of asteroids, then objects the size of small planets, called planetesimals, then larger protoplanets. Over tens of millions of years, The inner solar system was a chaotic region of growing rocky bodies colliding and merging. One of these bodies, growing in the region that would become the inner solar system, eventually accumulated enough material to form an object roughly similar in size to the current Earth, but still in the process of growing. Then, about 4.5 billion years ago, this proto-Earth collided with another rocky body, sometimes called Theia, which was roughly the size of Mars. The collision was one of the most violent events in the history of the solar system. The two bodies did not simply crash together. The impact was at an oblique angle, and the energy was so enormous that both objects were partially melted and vaporized. An enormous cloud of rocky material was ejected into orbit around the surviving proto-Earth. Over the course of a few thousand to tens of millions of years, this debris cloud coalesced into a single large body orbiting the Earth. That body is the Moon. The giant impact hypothesis is the leading scientific explanation for the Moon's origin, supported by multiple lines of evidence. The Moon has a composition very similar to Earth's mantle, consistent with the idea that much of its material came from the Earth itself. The Moon has a much smaller iron core than Earth, consistent with the idea that the iron in both Proto-Earth and Theia had already sunk to their cores before the impact, and the collision primarily ejected mantle material into orbit. And the Moon's rocks have been dated to about the same age as Earth's oldest materials. The Moon is not merely a beautiful night sky object. It has been essential to the development of life on Earth. The Moon's gravity creates the tides that have shaped Earth's coastlines and driven the evolution of intertidal ecosystems for billions of years. More importantly, the Moon stabilizes Earth's axial tilt. Without the Moon, the gravitational influence of the other planets would cause Earth's axial tilt to vary chaotically over millions of years, swinging from nearly 0 degrees, which would produce a climate with almost no seasons, to perhaps 60 or 85 degrees, which would produce extreme seasonal variation, with the poles pointing nearly at the sun in summer and directly away in winter. The stable axial tilt we have, about 23.5 degrees, provides the regular moderate seasons that have characterized Earth's climate for billions of years. The Moon is, in a real sense, a stabilizer of the conditions that made complex life possible on this planet. The Earth itself is not a simple, solid ball of rock. It is a layered structure of extraordinary complexity, from its solid iron inner core to its thin, fragile crust, where all of known life exists. The innermost region, the solid inner core, is a sphere of iron and nickel about 1,220 kilometers in radius, at a temperature of about 5,000 to 6,000 degrees Celsius, similar to the surface temperature of the Sun. Despite this extreme temperature, the inner core is solid because of the immense pressure at the center of the Earth, which is about 360 gigapascals, 3.5 million times atmospheric pressure. The pressure is so high that the iron cannot melt even at these temperatures. Surrounding the solid inner core is the liquid outer core, about 2,200 kilometers thick, composed of molten iron and nickel. The outer core is where Earth's magnetic field is generated. The liquid iron in the outer core is a conducting fluid that moves under the influence of the heat flowing outward from the inner core and the rotation of the Earth. This motion of conducting fluid generates electrical currents, and those currents produce a magnetic field. This process, called the geodynamo, has been operating continuously for billions of years, maintaining the magnetic field that surrounds and protects the Earth. Earth's magnetic field is invisible but essential. It creates a bubble called the magnetosphere that extends from inside the Earth out to tens of thousands of kilometers into space. The magnetosphere deflects most of the solar wind, the continuous stream of charged particles flowing outward from the sun. Without the magnetosphere, the solar wind would gradually strip away the atmosphere over geological time, as it has done to Mars, which lost its global magnetic field billions of years ago and has since lost most of its atmosphere to the solar wind. The thin, cold, tenuous atmosphere of Mars today is a consequence of its lack of magnetic protection. Earth's rich, thick, warm atmosphere exists in part because the geodynamo has been running since at least 3.5 billion years ago, protecting it continuously. Above the outer core is the mantle, a layer of solid rock about 2,900 kilometers thick that makes up the bulk of the Earth's volume. The mantle is not the rigid, static material it might seem. On the timescale of millions of years, the solid rock of the mantle flows like an extremely viscous fluid, driven by the heat from below. Hot rock rises slowly in broad plumes, spreads laterally near the top of the mantle, cools, and sinks again. This slow convective motion is what drives plate tectonics, the movement of the rocky plates that make up Earth's surface. Plate tectonics is one of the most remarkable processes operating on this planet, and one of the most important for life. The surface of the Earth is divided into about 15 major tectonic plates that move relative to each other at speeds of a few centimeters per year, roughly the rate at which your fingernails grow. Over millions and hundreds of millions of years, these small annual movements add up to enormous continental displacements. The continents have not always been arranged as they are today. About 250 million years ago, all of Earth's landmass was concentrated in a single supercontinent called Pangaea. Before that, other supercontinents existed, and before them, still other configurations. The continents have been drifting, colliding, separating, and drifting again for at least 3 billion years, possibly longer. Where two plates collide, the material at their edges is compressed and buckled upward, forming mountain ranges. The Himalayas, the highest mountains on Earth, were formed by the collision of the Indian subcontinent with Asia, a process that began about 50 million years ago and continues today. The Himalayas are still rising, lifted by the ongoing collision of the two plates at a rate of about 5 millimeters per year. Where one plate slides under another, the subducting material is recycled back into the mantle, returning to the vast geological cycle that has been operating since the planet formed. Plate tectonics is also responsible for the existence of the oceans. As the seafloor spreads at mid-ocean ridges, new ocean crust is continuously formed from magma rising from the mantle. The mid-ocean ridge system is the longest mountain range on Earth, over 65,000 kilometers in total length, winding through every ocean basin like the seam on a tennis ball. Most of it is completely unknown to anyone who is not a marine geologist. It sits beneath thousands of meters of water and complete darkness, host to one of the most remarkable ecosystems ever discovered: the ocean. We should spend more time here because the ocean is extraordinary and most of it remains unknown. The ocean covers about 71% of Earth's surface. Its average depth is about 3,688 meters. The deepest point is the Challenger Deep in the Mariana Trench in the western Pacific Ocean at a depth of about 10,935 meters, nearly 11 kilometers below the sea surface. If you placed Mount Everest at the bottom of the Challenger Deep, its summit would still be more than a mile beneath the waves. The pressure at the bottom of the Challenger Deep is about 1,100 times atmospheric pressure. At this pressure, the behavior of materials changes significantly. Water becomes slightly more compressible. The temperature is just above freezing, typically around 1 to 4 degrees Celsius. There is no light. There has never been any light. And yet life exists there. Scientists who have lowered cameras and sampling devices to the bottom of the Challenger Deep have found amphipods, small crustaceans, living in the sediment at the bottom of the deepest place on Earth. They have also found bacteria, foraminifera, and other microorganisms. Life has colonized the most extreme environment on the surface of this planet. Perhaps even more remarkable is the life found at hydrothermal vents, cracks in the ocean floor where superheated water laden with minerals rises from the geological activity below. The water emerging from hydrothermal vents can be 300 to 400 degrees Celsius, kept from boiling by the enormous pressure. Around these vents, in complete darkness. Far from any photosynthetic production of organic material, there are thriving ecosystems. Tube worms up to 3 meters long, crabs, shrimp, fish, octopuses, clams. These ecosystems are not powered by sunlight, but by chemosynthesis, the ability of certain bacteria to derive energy from the chemical reactions between the vent fluids and the surrounding cold seawater. The bacteria form the base of the food chain, and everything else builds on them. The discovery of hydrothermal vent ecosystems in 1977 transformed biology. Before that discovery, life was thought to be fundamentally dependent on photosynthesis, and therefore on sunlight. Hydrothermal vent ecosystems showed that life can sustain itself entirely on geochemical energy, independent of the sun. This discovery has enormous implications for the search for life elsewhere in the solar system, particularly on worlds like Europa and Enceladus, where hydrothermal vents may exist beneath the ice. Let your breathing settle a little deeper now. The ocean floor is down there, dark and cold, and full of extraordinary life, while you rest up here in the warmth. The bioluminescence of the ocean is worth pausing on. A remarkable proportion of marine life, particularly in the deep and mid-water regions of the ocean, is bioluminescent. It produces its own light through chemical reactions, typically involving a molecule called luciferin and an enzyme called luciferase. The light is produced for various purposes: to attract prey, to communicate with other members of the same species, to confuse predators, to illuminate the water ahead while hunting. In the deep ocean, where no sunlight penetrates, bioluminescence is the only light there is, and it is everywhere. If you could somehow travel through the water column at night, from the surface down to the deep sea, you would see flashes of blue-green light in every direction. Dinoflagellates, tiny single-celled organisms, light up when disturbed by water motion, creating the bioluminescent waves and boat wakes that have been observed by sailors for thousands of years. Deeper down, larger organisms produce sustained or patterned light. Anglerfish dangle luminescent lures above their mouths to attract prey. Viperfish flash their photophores in complex patterns. Jellyfish pulse with blue and green light. Comb jellies create rainbow interference patterns as light reflects from their beating cilia. The deep ocean is not dark and empty. It is dark and lit from within by the life that inhabits it. On some nights on beaches around the world, the bioluminescence of dinoflagellates makes the breaking waves glow electric blue. As each wave crashes and disturbs the water, millions of tiny organisms respond with light, creating a glow that runs along the wave's crest and flashes in the foam. This phenomenon has been witnessed throughout human history, celebrated by sailors and poets, used as an explanation for sea monsters and ghost ships. It is produced by organisms so small they are invisible to the naked eye, each one producing a flash so brief and dim it is nothing, but millions of them together, disturbed by the energy of a breaking wave, create a light show that can make a beach look like it is on fire with blue flame. The ocean's thermohaline circulation is a global system of ocean currents that carries heat and nutrients around the entire planet. It is driven by differences in the density of seawater, which depends on temperature and salinity. In the North Atlantic, the Gulf Stream carries warm, salty water from the tropics northward. As this water reaches the high latitudes near Greenland and Iceland, it cools and releases heat to the atmosphere, warming the climate of Western Europe. The cooled water, now denser, sinks to the ocean floor and flows southward along the bottom of the Atlantic, eventually making its way into the Indian and Pacific Oceans, where it gradually warms and rises again. This circulation, called the Atlantic Meridional Overturning Circulation, transports an amount of heat energy equivalent to about 1 million nuclear power plants continuously running. It is a global ocean heat pump, and it keeps the climate of Western Europe significantly warmer than it would otherwise be. Now let your thoughts drift to the air. The atmosphere you are breathing right now. Earth's atmosphere is about 78% nitrogen, 21% oxygen, and the remaining 1% various other gases, including argon, carbon dioxide, water vapor, and trace amounts of many other compounds. This composition is not a geological accident. The nitrogen has been in the atmosphere for billions of years, erupted from volcanoes, and retained because nitrogen is not easily consumed by chemical or biological reactions. The oxygen is almost entirely biological in origin. For the first 2 billion years of Earth's history, there was essentially no free oxygen in the atmosphere. Oxygen is a reactive gas that quickly combines with other materials, and without a continuous source to replenish it, it disappears from the atmosphere quickly. The source of Earth's oxygen is photosynthesis. About 2.4 billion years ago, cyanobacteria, tiny photosynthetic organisms, began producing oxygen in quantities large enough to overcome the capacity of the environment to absorb it. Oxygen levels in the atmosphere rose in an event called the Great Oxidation Event. This was catastrophic for the anaerobic organisms that had dominated life before it, for whom oxygen is toxic. But it opened the door for the evolution of aerobic life, organisms that use oxygen in their metabolism, which is far more energetically efficient than anaerobic metabolism. Every breath you take is breathing the byproduct of 2.4 billion years of photosynthesis. The sky is blue because of a phenomenon called Rayleigh scattering. When sunlight enters Earth's atmosphere, it is a mixture of all wavelengths of visible light appearing white. As it passes through the atmosphere, the light interacts with the molecules of nitrogen and oxygen in the air. These molecules scatter light in all directions, but they scatter different wavelengths of light by different amounts. Shorter wavelengths, toward the blue and violet end of the spectrum, are scattered much more strongly than longer wavelengths, toward the red and orange end. So as sunlight travels through the atmosphere, blue light is scattered in all directions across the sky. When you look at any part of the daytime sky away from the sun, what you see is this scattered blue light arriving from every direction. The sky is blue because the atmosphere preferentially scatters blue light in every direction, so no matter where you look in the sky, blue light is reaching your eyes from that direction. At sunrise and sunset, when the sun is near the horizon, sunlight must travel through a much greater thickness of atmosphere to reach you. By the time it has traveled that far, much of the blue light has already been scattered away in other directions. The remaining light is enriched in the longer wavelengths, the reds and oranges and yellows. This is why sunrises and sunsets are red and orange. The same atmosphere that gives you a blue midday sky gives you a red evening sky by the same mechanism operating over a longer path. Every thunderstorm on Earth is part of a global electrical system. At any given moment, there are about 2,000 thunderstorms in progress somewhere on Earth. They collectively produce about 100 lightning strikes per second, adding up to roughly 8 million strikes per day. Each lightning bolt carries about 1 billion joules of energy and heats the air around it to about 30,000 Kelvin, 5 times hotter than the surface of the sun, instantly and briefly. The tremendous expansion of this superheated air creates the shockwave we hear as thunder. But the lightning is not just a local phenomenon. It is part of what physicists call the global atmospheric electrical circuit. The Earth's surface carries a negative electrical charge. The ionosphere, the upper layer of the atmosphere, carries a positive charge. The potential difference between these two layers is maintained by the constant activity of thunderstorms, which act like generators, pumping charge from the surface to the ionosphere. In the fair weather regions between storms, this charge slowly leaks back down from the ionosphere to the surface as a gentle atmospheric current. The global circuit is always running, driven by thunderstorms, linking every point on Earth's surface through the atmosphere to every other point. The Schumann resonances are electromagnetic resonances of the cavity formed between Earth's surface and the ionosphere. This cavity acts like an enormous resonant chamber for extremely low frequency electromagnetic waves in the range of about 7.83 to 45 hertz. Lightning strikes around the world continuously excite these resonances, producing a background hum of electromagnetic energy at these frequencies. The resonances are named after Winfried Otto Schumann, who predicted them theoretically in 1952. They are sometimes called Earth's electromagnetic heartbeat because the lowest and strongest resonance at about 7.83 hertz, pulses at a rate somewhat analogous to a very slow heartbeat. These resonances can be detected anywhere on Earth with the right instruments. The planet is humming very quietly at frequencies below the range of human hearing, driven by the global symphony of its thunderstorms. Let your breathing be slow and quiet now. The planet is humming below you. The ocean is moving in its vast global currents. The magnetic field is deflecting the solar wind in silence far above the atmosphere. The whale in the Pacific is still singing, somewhere deep in the dark water. Water is one of the most extraordinary substances in the universe, and Earth has an abundance of it that is unusual among the rocky bodies of the inner solar system. The oceans contain about 1.335 billion cubic kilometers of water. In addition, there is water locked in glaciers and ice sheets, in groundwater aquifers, in lakes and rivers, in the atmosphere as water vapor, and in the bodies of living organisms. All of this water has been cycling through Earth's systems for almost 4 billion years. The water cycle begins with evaporation, primarily from the ocean surface, driven by heat from the sun. Water molecules at the surface absorb enough energy to break free of the liquid surface and enter the atmosphere as water vapor. This vapor rises with warm air currents, cools as it rises, and condenses into tiny water droplets or ice crystals that form clouds. The clouds are carried by winds, sometimes for thousands of kilometers. Eventually, the water droplets, or ice crystals, coalesce into drops large enough to fall back to the surface as rain or snow. Some of this precipitation falls directly back into the ocean. Some falls on land, where it runs off into rivers and streams that carry it back to the sea, soaks into the ground where it enters aquifers and is stored for years or centuries or millennia before emerging in springs, or falls on glaciers and ice sheets where it is locked in ice for thousands of years before melting. The molecules of water in any given glass of water have made this journey countless times. They have been in the ocean, in clouds, in rain, in rivers, in the groundwater, in the ocean again, in ice ages, locked in glaciers, released again. The water in your body has been through this cycle over and over for billions of years. Some of it may have been in the cells of a dinosaur. Some may have been part of a glacier that covered a landscape that is now a warm tropical beach. The water is very old, and it has been everywhere on Earth, cycling and cycling and cycling. The forests of the world are among the most complex and ancient systems on Earth. The Amazon rainforest covers about 5.5 million square kilometers, larger than the entire continent of Australia, and contains an estimated 390 billion trees of about 16,000 different species. The forest generates about 20% of the oxygen in Earth's atmosphere. It transpires so much water vapor that it creates its own weather system, producing cloud formations and rainfall that extend far beyond the forest itself. Scientists have described the Amazon as a biotic pump, a system that draws moisture inland from the Atlantic and recycles it through the forest repeatedly, supporting not only the forest itself, but the agricultural systems of much of South America. The forests of the world taken together, the Amazon, the boreal forests of Canada and Russia, the temperate rainforests of the Pacific Northwest and Patagonia. The tropical forests of Southeast Asia and Africa contain an estimated 3 trillion trees. 3 trillion. Each tree is a living structure that may be decades or centuries or even millennia old, pumping water from the soil to its leaves, converting carbon dioxide and sunlight into wood and leaf and fruit, providing habitat for thousands of other species. Communicating with neighboring trees through fungal networks in the soil, competing and cooperating simultaneously in a system of such complexity that scientists are still working out its basic rules. The oldest individual living trees on Earth include Methuselah, a Great Basin bristlecone pine in California's White Mountains, whose age has been determined by tree ring counting to be approximately 4,855 years old as of 2024. This tree was already 1,000 years old when the pyramids at Giza were being built. It has been growing in the rocky, cold, dry heights of the White Mountains through the entire recorded history of human civilization. The tree that you could touch with your hand, running your hand along its gnarled, ancient bark, is older than the oldest known human writing. But the oldest living organism on Earth is not a single tree. It is a clonal colony called Pando, located in Fish Lake National Forest in Utah. Pando is a grove of quaking aspen trees, about 47,000 individual trunks that are all genetically identical because they are all stems of a single root system. The whole grove, spread across about 43 hectares, is a single organism connected underground. The root system of Pando is estimated to be about 80,000 years old, possibly older. When early modern humans were first moving into Europe, when the last Neanderthals were beginning to disappear, Pando was already there, its roots spreading quietly in the Utah soil, its aspen trunks trembling in the mountain wind. The Great Barrier Reef, off the coast of northeastern Australia, is the largest living structure ever built by living organisms on Earth. It extends for about 2,300 kilometers along the coast of Queensland and contains more than 2,900 individual reefs and 900 islands. It is home to over 1,500 species of fish, 4,000 species of mollusks, 240 species of birds, and countless other organisms. The reef has been building for about 500,000 years, though most of the current structure has been growing for about 8,000 zone years since sea levels stabilized after the last ice age. The reef is made of coral polyps, tiny animals related to jellyfish that secrete calcium carbonate skeletons. Each individual polyp is tiny, a few millimeters in diameter. But working together over centuries, they have built a structure that can be seen from space. The reef is visible from low Earth orbit, a pale blue-green shimmer against the deeper blue of the coral sea, a biological construction of such scale that astronauts have reported it as one of the most striking features of the coastline of Australia. The migration of birds is one of the most extraordinary biological phenomena on Earth. Each year, billions of birds travel between their breeding grounds and their wintering grounds, covering distances of thousands of kilometers. The Arctic tern makes the longest migration of any known animal, traveling from its breeding grounds in the Arctic to its wintering grounds in the Antarctic and back again each year, a round trip of about 70 to 90,000 kilometers. In a lifetime, an Arctic tern may travel the equivalent of 3 trips to the moon and back. How birds navigate these immense distances is one of the most fascinating questions in biology. They use multiple methods simultaneously. They navigate by the stars, using the pattern of stars and the night sky to determine direction. They use the position of the sun during the day, combined with an internal clock that tells them where the sun should be at any given time. They detect Earth's magnetic field using specialized cells in their beaks and possibly in their eyes, and use this to determine both direction and geographic position, a kind of biological GPS. They use landmarks, coastlines, river valleys, mountain ranges. They use infrasound, very low frequency sound waves that carry for thousands of kilometers, to locate coastlines and other geographical features they have learned to associate with their routes. The internal maps that migratory birds carry, built from all these sensory inputs, are among the most complex and precise navigational systems in the animal kingdom. The deep biosphere is one of the most recently discovered and least understood aspects of life on Earth. For most of human history, it was assumed that life on Earth was concentrated near the surface, in the oceans, on land, in the air. The deep subsurface, the miles of rock beneath our feet, was assumed to be largely sterile. This assumption began to be overturned in the 1980s and 1990s as scientists drilling into deep rock formations began to find bacteria and other microorganisms in rock samples from hundreds and even thousands of meters below the surface. These microorganisms live in the pores and fractures of rocks, deriving energy from chemical reactions between the rock minerals and water in complete darkness, at high temperatures and pressures, isolated from the surface world for millions of years. The total mass of life in Earth's deep biosphere is estimated to be roughly comparable to the total mass of all life on the surface. There may be as much life underground as above it, hidden in the rock, moving at geological timescales, metabolizing so slowly that a single cell might divide only once every 1,000 years. Some of the microorganisms in the deep biosphere may have been isolated in their rock fractures for millions of years, descended from surface organisms that were carried down by groundwater long before humans existed, before mammals existed, before even dinosaurs existed. The deep rock is full of ancient, slowly metabolizing life that knows nothing of sunlight or seasons or the passage of surface time. Ice cores are one of the most important scientific archives on Earth. In Antarctica and Greenland, ice sheets have been accumulating layer by layer for hundreds of thousands of years. Each year's snowfall traps within it a sample of the atmosphere of that year, tiny bubbles of air, particles of dust, traces of volcanic ash, pollen grains, chemical signatures of sea surface temperatures, and atmospheric circulation patterns. By drilling down through the ice and analyzing each layer, scientists can reconstruct the history of Earth's climate in extraordinary detail. The deepest Antarctic ice cores extend back about 800,000 years, through 8 complete ice age cycles, recording the rise and fall of global temperatures, the variation of greenhouse gas concentrations, the timing of volcanic eruptions and their effects on the climate, and much more. These ice cores have revealed that the concentration of carbon dioxide in the atmosphere has varied between about 180 parts per million during ice ages and about 280 parts per million during warm interglacial periods over the past 800,000 years. The current concentration of carbon dioxide in the atmosphere is over 420 parts per million, higher than at any point in the past 800. 00 years, and possibly the past 3 million years. This anomaly, this departure from the natural range of the past million years, is the primary evidence for the current anthropogenic change in Earth's climate. Earth's rotation is very gradually slowing down. The friction of the ocean tides, raised by the moon's gravity and dragging against the ocean floor, acts like a very gentle brake on Earth's rotation. The day is getting longer, by about 1.4 milliseconds every century. This means that about 600 million years ago, an Earth day was only about 21 hours long, and about 4 billion years ago, when the moon had just formed and was much closer to Earth, the day may have been only 6 hours long. The Earth was spinning nearly 4 times faster than it does today. As the Earth slows, the moon gradually moves farther away, gaining the orbital energy that the Earth is losing to tidal friction. The moon is currently moving away from Earth at about 3.8 centimeters per year. In about 50 billion years, if the sun were still shining, the Earth and moon would be mutually tidally locked, each one facing the same face toward the other forever, the day having grown to equal the month. Earth from space is one of the most beautiful and moving sights available to any human being, and the relatively small number of people who have seen it directly have consistently reported a profound shift in perspective. Astronauts who see Earth from orbit for the first time almost universally describe the experience as transformative. They describe seeing the thin blue line of the atmosphere, a fragile skin of air only 12 to 15 kilometers thick compared to the planet's 12,742 kilometer diameter, proportionally thinner than the skin of an apple. They describe the blackness of space surrounding this fragile, luminous sphere. They describe how the political boundaries they know from maps are completely invisible, how all of the human world of nations and borders and conflicts is contained within this one glowing world with no dividing lines. They describe a feeling of deep identification with the entire planet rather than with any one nation or culture. This shift in perspective has been called the overview effect, and it has been described by astronauts from dozens of different countries who have seen it regardless of their cultural or political backgrounds. You are on that sphere right now. You are on the fragile, glowing, ocean-covered, cloud-wrapped, magnetically protected, biologically rich, geologically active, ancient, extraordinary sphere that is spinning slowly in the dark, carrying you and every other person, an animal and tree and ocean current, and migrating bird and deep-sea whale and ancient aspen root system through space. Everything you know is here. Every person you have ever met or loved is here. Every city, every mountain, every ocean, every forest, every coral reef, every glacier, every deep rock biosphere with its billion-year-old bacteria is here on this one world. And right now, the planet is dark where you are. The sun has set. The stars above the atmosphere are burning, or some of them have already burned out, and you are seeing their ancient light. The ocean is moving in its vast, deep, silent currents. The forests are breathing, trading oxygen for carbon dioxide through millions of leaf pores in the cool night air. The magnetic field is deflecting the solar wind. The Schumann resonances are humming at 7.83 hertz. The whale in the Pacific is still singing, moving through the dark water, its voice carrying at 1,500 meters per second through the cold, still sea. And you are here, on this world, breathing this ancient oxygen, drinking this ancient water, made of atoms that have been on this planet for 4.5 billion years. Gravity is holding you in place. The planet is beneath you, solid and vast and warm at its core. The atmosphere above you is a thin, perfect blanket of gas, warm enough and thick enough and oxygen-rich enough to sustain you through every second of this night. Before we rest fully, there are more extraordinary facts about this world that deserve a moment of quiet appreciation. Scientists estimate that Earth harbors approximately 8.7 million species of living organisms, of which only about 1.2 million have been formally described and named by scientists. The remaining 7.5 million or so species are unknown to science, undiscovered, unnamed. Uncharacterized, the vast majority of these undescribed species are insects, fungi, marine invertebrates, and microorganisms. New species are described at a rate of about 15,000 to 20,000 per year, which means that at the current rate, it would take hundreds of years to describe them all, even without accounting for the species that go extinct before they are discovered. The biodiversity of Earth has been accumulating for about 3.5 billion years since the first recognizable cells appeared in the fossil record. Each species that exists today is the product of an unbroken chain of reproduction going back through every ancestor to those first single-celled organisms. Every ant, every oak tree, every deep sea fish, every bacterium in the deep biosphere, every coral polyp in the Great Barrier Reef, every Arctic tern on its 70,000-kilometer migration has been connected to every other living organism on Earth through this unbroken chain of descent from common ancestors. In a very real biological sense, you are related to every other living thing on this planet. You and the whale in the Pacific share common ancestors. You and the ancient bristlecone pine in California's White Mountains share common ancestors. You and the bacteria living in your gut, some of which are essential to your digestion and immune function, share common ancestors from billions of years ago. The fungal networks that connect trees in a forest, sometimes called the Wood Wide Web, are one of the most extraordinary discoveries of recent ecology. Beneath the forest floor, the roots of trees are connected to each other through a vast network of fungal filaments called mycelium. This network, formed by mycorrhizal fungi that live in a symbiotic relationship with tree roots, can connect virtually every tree in a forest to every other tree. Through this network, trees can transfer nutrients to neighboring trees that need them. A mature tree shaded from the sun can receive sugars produced by photosynthesis from a neighboring tree that has better sun exposure. Trees that are dying have been observed to transfer their remaining resources into the network before they die, providing nutrients for seedlings growing nearby. The network transmits chemical signals that alert trees to the presence of insect pests or pathogens, allowing neighboring trees to increase their production of defensive compounds before the threat reaches them. The mycorrhizal network is not controlled by any individual organism. It is an emergent system, a distributed intelligence of sorts, operating through the chemistry of millions of individual fungal filaments and tree roots over areas of many hectares. A single teaspoon of healthy forest soil can contain several kilometers of fungal filaments. The forest is not a collection of individual trees competing in isolation. It is a community connected at the root level, sharing resources and information through a living network that is almost entirely invisible to the eye. Let your breathing settle even more gently now. The forest is connected below the surface. The mycelium is there in the dark soil, moving nutrients and signals. And beneath the mycelium, deeper still, the rock and the bacteria in the rock, and the heat from the mantle, and the iron of the outer core, and the solid iron of the inner core, all the way down, the whole layered planet, resting beneath this surface, where life has found a way to exist in almost every conceivable form. The tardigrade, also known as the water bear or moss piglet, is one of the most remarkable organisms on Earth. These tiny animals, typically between 0.1 and 1.5 millimeters in length, are found in virtually every habitat on the planet, from the highest mountain peaks to the deepest ocean trenches, from the Antarctic ice to the hottest hot springs. They are best known for their extraordinary ability to survive extreme conditions that would kill virtually any other complex animal. When conditions become hostile, tardigrades can enter a state called cryptobiosis, in which they retract their legs, curl into a ball called a ton, and essentially shut down their metabolism to a tiny fraction of its normal rate. In the ton state, tardigrades have been shown to survive temperatures from -272 degrees Celsius, just 1 degree above absolute zero, to +150 degrees Celsius. They can survive pressures 6 times greater than the deepest ocean. They can survive intense radiation doses hundreds of times higher than would kill a human. They can survive complete desiccation, losing all but about 3% of their water content for decades, and then be revived by adding water. They have even survived brief exposure to the vacuum of space. Tardigrades have been on Earth for about 530 million years. They predated the dinosaurs by hundreds of millions of years. They survived all 5 of the major mass extinction events in Earth's history. They are, by any measure, among the most resilient and successful organisms that have ever evolved on this planet. And they are here right now, in the moss on a stone wall near your window, in the lichen on a tree, in the soil of a garden, in the debris at the bottom of a forest stream. Millions of them, invisible, going about their lives in a scale so small that only a microscope can reveal them. The caves of the world are among the least explored environments on Earth's surface. There are estimated to be hundreds of thousands of cave systems around the world, of which only a fraction have been explored by humans. Caves offer a completely dark, temperature-stable, humidity-rich environment that harbors specialized ecosystems found nowhere else. Cave animals called troglobites have evolved over many generations of isolation in the dark, typically losing their eyes and pigmentation, which are metabolically costly in an environment where they serve no purpose, and developing other sensory abilities, longer antennae, more sensitive lateral lines in cavefish, enhanced sensitivity to vibration. Some caves contain organisms that have been isolated from the surface world for millions of years. The Muval Cave in Romania sealed from the surface for about 5 million years, contains an ecosystem of about 50 species that exist nowhere else on Earth, including spiders, centipedes, leeches, water scorpions, and bacteria. All of these organisms are sustained by chemosynthesis, deriving energy from hydrogen sulfide and methane seeping from the geological formations below, with no input of sunlight or surface-produced organic material whatsoever. It is a completely self-contained world within a world. The Sahara Desert, now the largest hot desert on Earth, was not always a desert. Approximately 11 to 5,000 years ago, during a period called the Green Sahara or African Humid Period, the Sahara was covered in lakes, rivers, grasslands, and forests. The change in Earth's orbit and axial precession during this period shifted the African monsoon system northward, bringing significantly more rainfall to what is now the Sahara. The lakes of the Green Sahara included a body of water called Mega Lake Chad, which at its largest extent was larger than the Caspian Sea. Hippopotamuses, crocodiles, giraffes, and early human populations lived throughout the region. Evidence of this green past is preserved in rock art, in fish bones and hippopotamus fossils found in locations that are now hundreds of kilometers from any water, and in satellite imagery that reveals the ghost of ancient river channels beneath the present-day sand. The return of the Sahara to a wetter state is not impossible. Earth's orbital cycles continue to change slowly, and in several thousand years, the precession of Earth's axis will again shift the African monsoon system. But the timing and extent of any future Green Sahara is uncertain and will be modified by the current changes in Earth's climate. The night sounds of Earth are one of its least noticed but most extraordinary features. On a quiet night in a natural setting, far from human noise, the Earth produces a continuous, layered acoustic environment. In a tropical forest, frogs and insects produce a constant pulsing chorus that varies in intensity but never stops. In a temperate forest in summer, crickets and cicadas fill the air with the electromagnetic frequency of their stridulation. At the ocean shore, the rhythm of waves carries for miles. In a desert on a clear night, there may be near silence punctuated by the calls of owls and coyotes and the very occasional sound of wind. In an Arctic summer night, there may be birdsong even at midnight, because the sun never fully sets and the birds have no darkness in which to sleep. These sound environments have shaped animal evolution for hundreds of millions of years. The timing and frequency and patterning of animal calls are adapted to maximize their transmission through the local acoustic environment. The low resonant calls of howler monkeys carry for 3 kilometers through dense forest. The high, complex songs of songbirds are adapted to the vertical gradient of sound in forest edges and canopies. The infrasound calls of elephants, below human hearing, carry for tens of kilometers across open savannas, allowing elephant family groups to maintain contact across distances that would be impossible with higher frequency calls. The monarch butterfly migration is one of the most extraordinary journeys made by any animal on Earth. Every autumn, millions of monarch butterflies in eastern North America fly south and west from their summer breeding grounds across the United States and Canada to overwintering sites in the Oyamel fir forests of central Mexico, a distance of up to 4,500 kilometers. The butterflies that make this journey have never been to the overwintering sites before. They are flying to a destination they have never seen, using a navigation system that relies on the position of the sun, corrected for time of day by an internal circadian clock, and possibly on Earth's magnetic field. When they arrive in the mountains of central Mexico, they roost by the millions in the trees, clustering so densely that the branches bend under their weight, creating a living, slowly moving blanket of orange and black. The overwintering monarchs remain more or less dormant through the winter, then begin to fly north in spring, but no individual monarch makes the entire round trip. The butterflies that fly north in spring are the same individuals that flew south in fall, but they only reach Texas or the southern United States before they reproduce and die. Their offspring, born in early spring in the southern states, continue the journey northward. It takes 3 or 4 generations of butterflies to complete the spring migration north, and it is the great-grandchildren or great-great-grandchildren of the butterflies that overwintered in Mexico that will fly back to Mexico the following fall, navigating to a place they have never been using an inherited map. Fireflies light up summer nights in temperate and subtropical regions of the world with a display that is both beautiful and extraordinary from a scientific perspective. There are about 2,000 species of fireflies worldwide, each with its own distinctive flash pattern. The flashes are produced by the same bioluminescence mechanism found in deep-sea organisms, luciferin and luciferase, but the purpose here is communication for mating. The male flies through the air, flashing his species-specific pattern. The female, perched on vegetation, flashes a response after a species-specific delay if she is receptive to mating. The male navigates toward her by following her flash, and the conversation continues. Some species of firefly produce synchronized flashing, in which thousands of individuals in a tree or forest synchronize their flashes so that they all light up simultaneously and go dark simultaneously over and over, producing a dramatic pulsing display. The mechanism by which thousands of independent organisms spontaneously synchronize their flashing is a beautiful example of emergent behavior. The appearance of complex organized patterns from the interactions of many simple individuals following simple local rules. The seasons of Earth are driven by the tilt of its axis, 23.5 degrees relative to the plane of its orbit. As Earth orbits the Sun, the northern hemisphere is tilted toward the Sun for half the year, and away from the Sun for the other half. When the northern hemisphere is tilted toward the Sun, it receives more hours of sunlight per day, and the sunlight arrives at a less oblique angle, delivering more energy per unit area. This is summer. When the northern hemisphere is tilted away from the Sun, there are fewer hours of daylight, and the Sun's angle is more oblique, delivering less energy per unit area. This is winter. The southern hemisphere experiences the opposite. The solstices are the moments when Earth's axial tilt produces the maximum or minimum solar elevation at noon. The summer solstice in the northern hemisphere, around June 21, is the day with the longest period of daylight and the sun at its highest point in the sky at noon. The winter solstice, around December 21, is the shortest day, with the sun at its lowest noon elevation. Between the solstices are the equinoxes, the moments when the sun is directly above the equator and day and night are of approximately equal length everywhere on Earth. The Grand Canyon, cut by the Colorado River through the Colorado Plateau over the past 5 to 6 million years, exposes in its walls one of the most remarkable geological records on Earth. The canyon is about 450 kilometers long, up to 29 kilometers wide, and about 1,600 meters deep. The rocks at the very bottom of the canyon, the Vishnu Basement Rocks, are about 1.84 billion years old. The rocks at the top, the Kaibab Limestone, are about 270 million years old. Walking down into the canyon is walking backward through more than 1.5 billion years of Earth's history. Each layer of rock represents a different environment, a different climate, a different sea level. The marine fossils near the top of the canyon tell of an ancient shallow sea that covered what is now the American Southwest hundreds of millions of years ago. The older rocks deeper in the canyon were themselves metamorphosed from still older rocks by heat and pressure. Their original identity transformed. The Grand Canyon is a library of time cut open by a river that found its way to the sea. The planet is extraordinary, not in an abstract intellectual way, but in a tangible, immediate way. The oxygen in your lungs right now was released by photosynthesis, by plants and algae and cyanobacteria, converting sunlight and carbon dioxide into sugar and oxygen. The same process that has been oxygenating the atmosphere for 2.4 billion years. The nitrogen in the air around you has been circling through the atmosphere and through the bodies of living organisms for billions of years. The water vapor in the air you breathe was ocean water, and rain, and river, and glacier, and ocean again, cycling continuously since the seas formed. The gravity holding you in place is the cumulative attraction of every atom in the planet, 6 trillion kilograms of rock and iron and nickel, all pulling gently, steadily, continuously. Let the weight of your body settle completely into the surface beneath you. Let your muscles fully release. Let your breath come slower and quieter. You do not need to do anything right now. The planet is taking care of everything. It has been taking care of everything for 4.5 billion years. Tonight is no different. The tectonic plates are moving imperceptibly slowly, a few centimeters per year. The mountains are rising and eroding simultaneously on timescales of millions of years. The ocean currents are carrying their heat around the globe. The forest canopy is still breathing. The bioluminescent plankton are waiting for a wave to disturb them. The deep-sea creatures are moving through the dark. The ice cores in Antarctica hold their 800,000-year climate record in silence. The Great Barrier Reef is alive with the slow work of 1 billion coral polyps. And here, in this warm, quiet room, the whole earth holds you. Sleep now. You are in good hands. You have always been in good hands. The planet has been preparing this exact moment for 4.5 billion years, and it has set aside this night and this warmth and this breath just for you. Good night.